Alright, today we're going to talk about the moon, seasons, and eclipses. So let's start with the moon. So this is the near side of the moon. We know the most about it. We've been studying it for the longest amount of time. You notice there are the dark crater on parts of the moon. They're called mar. Those are the regions we originally thought were oceans on the moon. We now know that they're just dark regions where magma fields once were when the moon first formed. And also notice all the craters. There's no atmosphere, so there's no weathering from rain or any of those other water-based things on the moon because we do not have an atmosphere or liquid water moving on its surface. So things you want to keep in mind, the features are impact craters, regolith, which is the dirt on the surface, maria or mar, those dark, large areas we looked at, highlands are your lighter color areas, and rills are the valley-like areas on the surface of the moon. The moon also goes through phases. So the phases range from new to waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, and waning crescent. And it's based on the amount of lit portion of the moon we can see. So if you look at our circle, we only see what's inside the circle. So you can kind of cross off the outer part, and what you would see on Earth would be a crescent in this particular phase. So if we look at the first one, it's a crescent, and it's lit on the right side, so that's a waxing crescent. So each time you would block off, and that tells you how much of the moon you would see, and that would give you the phase. Tides are also influenced by the moon, particularly the moon, but also the sun. So when tides are caused by both the moon and the sun, they get special names. So if you think about it, so here's your normal tide. So the moon pulls in one direction, it causes a bulge as it pulls outward, and that pulls the water literally ashore as the Earth rotates away. The special tide names are spring tide and neap tide. So spring tide is when you have a new or full moon because they're all in line. You have the sun over here. They're all in a straight line, which gives you higher than normal high tides. It also would give you a lower than normal low tide. Neap tide now would lower your high tides because you have the moon pulling in a different direction than the sun. It's at a right angle. So that's a neap tide. Now, we are always seeing the same side of the moon because we're in what's called a synchronous rotation, which means the moon's speed of rotation and revolution are equal, and we're always looking at one side. So that's just showing you as it goes through its phases the part that we actually see. Lunar eclipses are our next topic. So lunar eclipses are when you have, here's a picture. So you've got the Earth, the sun would be over here, it's casting a shadow, the moon enters into the shadow, either completely or partially, and it would give it a reddish tint. Now, if you look in this picture, you can see there's two parts of the shadow. The penumbra is the partial shadow, and then that darker portion of the shadow is called the umbra. During a total lunar eclipse, you get this red color. So this is showing you what the color would look like. And that's a bigger picture of it. They usually last about 2 hours, and they only generally occur a couple times a year, but always during the full moon phase. And this is just your calendar. These are an older set of calendars. So we had one back in June of 2012. We also had one pretty recently in April. Solar eclipses are a little bit more rare because you have the moon going in between the Earth and the sun, and it casts a shadow onto Earth. Inside of that shadow, you would see a solar eclipse. So it's only in a small area of Earth. It only lasts about 10 minutes, and they're kind of chaotic and sporadic as where they appear. So it would look like this, though. So you see the moon's blocking it out. We now can see the chromosphere and the corona, which is not normally seen. Normally the photosphere, the brightest layer, is the only layer that's visible to us here on Earth. But during the eclipse, it's actually blocked out, allowing us to see those other layers. This is the diamond ring effect from that. When you get a little blast on one side. So other things you want to think about, so we're not in a perfectly circular orbit. We're actually in an eccentric orbit. So we're closer to the sun on January 3rd, and that's called perihelion. We're further from the sun at aphelion, which is in June. And then the moon does the same thing. It's closest to us at perigee and furthest from us at apogee. So annular solar eclipses are even more rare. Basically, what you want to take home from this is it's really rare to even have a solar eclipse, particularly one when it's at perigee. All right. So these are your eclipses. It has to be when the moon and sun cross the same point in the sky for us to actually be in the shadow. So generally that doesn't actually occur. So normally we would just see your regular pattern and your regular changes in the phases. It's only on occasion where they have everything in line and you would have the chance to actually see a solar eclipse or a lunar eclipse. Solar eclipses are during new phase, lunar eclipses during full phase. Now, the seasons. So the seasons are directly related to the amount of direct sunlight a portion of the Earth receives. So you notice the northern hemisphere on each the backward or back and front portion of this little diagram are getting equal sunlight. That it's not facing the sun and it's not facing away from it. Those are your equinoxes. Your fall equinox or autumnal equinox occurs in September. Your vernal equinox or spring equinox occurs in March. Now, your solstice depends on which direction you're pointing. So in this little picture on the side to the right, the northern hemisphere is facing away from the sun. And if you notice, the northern polar regions are shadowed. In fact, the North Pole won't receive any light during winter solstice, or the darkest day of the year. During summer solstice, it's the exact opposite. The northern hemisphere is facing towards the sun, getting direct sunlight. The North Pole would not receive any darkness at this time. It would be in light the complete portion of this time. And that's the summer solstice, usually in June. So the summer solstice is around June 20th, winter solstice around December 20th. During summer, we're facing getting more direct light, longer summer hours than we could do in the winter when we're facing away and getting shorter amounts of sunlight.